Okay guys, this is going to be a quick overview of your Kelvin bicycle safety light, the soldering project that we've got for you. Couple items before you get started. Make sure you have a heat sink, either your hemostats or an alligator clip or one of the commercial heat sinks. You're going to want a pair of diagonal cutting pliers, a needle nose pliers might be helpful as well. You might need a desoldering tool, a desoldering pump, or a solder wick. Will work well. It's only if you make a mistake you have to remove something, but good to have if needed. And of course your soldering iron with a damp sponge, and I prefer the steel wool for cleaning and tinning your tip. Of course we're going to work with 60-40 solder, so make sure you have some rosin core solder to work with, and it's good if you have a set of helping hands to use the third hand there to get into the project. Now as we get started here, let's take a look at the instruction packet and look at the basic circuit schematic. Let's see if I can get that whole thing in for you so you can kind of see what's going on. What we have at the heart of our project is the 555 timing IC chip. This 555 timer set up to operate in a monostable state. Basically the monostable clock impulses are driving a JK flip-flop IC chip over here, and in the end the outputs of flip-flop outputs are driving these two or inputs to these two NPN transistors, which essentially are controlling two different LED banks. So what it looks like is we kind of have a rotating flashing light of red LEDs as we go along here. So when one JK flip-flop is high, the other one will be low, and vice versa. So it's kind of alternating back and forth there. Before you get started, always read the instruction panel packet thoroughly. Remember your basic safety guidelines as we've been practicing in class all along, and make sure you do a complete inventory of the part kits that's given to you. This is what the top side of your circuit board will look like, your PCB, and this is it right here. And if you flip that over, you'll be soldering your components on the copper traces on the back side of that PCB right there. Do a full parts list inventory. You're going to have 7 resistors, and those resistors are little quarter-watt resistors, like that guy right there. I'm sorry, I guess those are quarter-watt resistors. We're going to have 2 capacitors here. We have an electrolytic capacitor and a ceramic disc capacitor, and that's those 2 guys right there. You will have your 2 transistors, are our semiconductors, along with the IC timing chips. You'll have the 4027 as our flip-flop and the 555. So quick note about our IC chips. The little notch on the end, if you orient that little notch, or you see on the 555 it has a little dot there. If you orient that to the left, that's going to help you identify your pin numbers. So the lowermost pin, use this lead to point this out. Here's our notch on our JK flip-flop. This is going to be pin 1, and we go in a counterclockwise fashion around. So pin 1, 2, 3, 4, 5, 6, 7, and 8, and then across from 8 will be 9, and we count back to pin 16. The same thing with our 555 timing. The little notch, the little dot right here, is going to orient us to pin 1, 2, 3, and 4, and across is 5, 6, 7, and 8. One of the things to pay attention is I am giving you the dip sockets, the dual inline package sockets, so you don't damage the chips during your soldering. So remember, if you had too much heat on a semiconductor, you can damage that IC. when you put these on, these little sockets have a notch, and that also can help us orient our chip. So align the notch to the direction that the chip should be aligned. So when you look at the printed circuit board, for example, our flip-flop is going right here, and you see there's a little notch there. So make sure you orient your ICs in the proper direction. If you do not, it will not work. Some other orientation things you want to pay very close attention to. We have electrolytic capacitors. So that electrolytic capacitor, the positive lead is going to be on this side, the negative lead is going to be on that side, and our negative cathode lead has a little bulge on it, and the positive lead is where the indentation is on that electrolytic capacitor. Very important here, the LEDs will not work if they are not oriented in the proper manner. And so the diagram really helps you out. The flat side is the cathode side of an LED. I'm going to take a look here at the big LED and see if we can, well, we really can't perceive when you look at it on end. I don't think we can really see the flat notch. So our other giveaway, and sometimes when they're making those LEDs, those flat notches don't come out. The other giveaway is the short lead is the cathode side and the long lead is the anode side. So when you're looking at your LEDs, pay attention to the lead length. The short lead will be the cathode, and it may have a flat notch on it. We'll take a look at these smaller 5mm guys. This one will look to see, maybe, just maybe, I don't think I can, it shows up there. This one does have a flat notch, but it's a little bit harder to pick up here with the camera. But there is a flat notch on the shorter lead, the cathode side. Very important to pay attention to that orientation when you're setting it on this circuit. Again, the circuit will not work if you don't put the components in the correct orientation. You're going to have two NPN transistors. Remember, with a transistor, you look at the flat side facing towards you, and on this particular transistor package, this is oriented as emitter, base, and collector. Emitter, base, collector. Base is the center lead with this particular transistor package. If you follow the markings, this is pretty much idiot-proof in the sense of they have drawn the orientation for you on the PCB. One thing to pay attention with our semiconductors, we do want to heat sink those, so you want to heat sink your transistors, put the hemostats between the iron and the component. Do not solder. The whole reason I'm giving you a socket here is so you don't damage the IC pit. Do not put the IC chip in the socket before you solder it. Let's wait till the very end when we've assembled the whole thing to then place the IC chips in their sockets. So the socket allows you to prevent damage. You do want to make sure you don't bridge these little holes. Each one of those holes are independent, and you don't want solder to bridge over on them. So make sure practice a good solder technique, especially ones that have traces coming off them, because they're the ones that are directly involved within the circuit itself. So practice isolating your solders. You should have a little solder drop on each one, and they should not bleed together. You shouldn't have any bridging of your soldering. So this is our second level kit. It's the next step up. Designed a little bit, give you a little more of a challenge. Hopefully you are able to complete this and enjoy this. Good luck with the assembling of the Kelvin bicycle safety light.